Okay, we have 82 now. Okay. So, good evening, everyone. Good evening again. So, yes, Nirav sir, can we start now? I think whoever are like left, they'll join in between.
Sure, we can start.
Yeah. So, yeah, Ria, it's up to you. Start.
Good evening, one and all. As you already know, the Google Developer Students Club of Christ into the University is celebrating the 30 Days of Cloud. So, today we have amongst us a very special guest, Mr. Nirav Kothari, a technical architect at Quantiphi, Mumbai. Sir is a Google Cloud expert with 16 years of experience. He has a strong hold on application designing and development, exhibited during association with various clients globally. Mr. Kothari is a co-organizer of the Google Developers Group Club Cloud Mumbai community since its inception and helps startups strategize their IT and infrastructure and use the leverage provided by cloud to achieve their business goals. We heartily welcome you, sir, and thank you for your enriching presence. Over to you, sir.
Thank you so much. Hi, everyone. It's my pleasure, completely my pleasure, that I'm getting a chance to speak to such a talented crowd today. I hope by the end of this session, you take away something or other at the end of the session. Today, I'm going to speak about something really exciting, really challenging as well, and something that, is being appreciated too much in today's world. Okay. And I would want all of you to, you know, please pay attention if you think that, if you have any question or you want to clarify certain thing, you can post your questions in the chat, and probably at the end of the session we can take up all the quiz with the help of hosts here. Uh, with that, I would like to start the presentation, and I'll try to share my screen. Give me a sec. Okay. Can somebody please confirm whether you
Yeah,
guys are able to see my
it's
screen?
visible. Yeah.
Okay, perfect, perfect. So I'm going to talk about how do you start with your cloud computing journey. Okay, what it is, why you should start learning a cloud, and why you should opt for Google Cloud in particular. So I'm going to talk about that. And in case if you have any question, as I mentioned, please feel free to put your questions in the chat. A little bit of introduction about me. I'm a Google developer expert from Mumbai, and I'm basically into Google Cloud Platform category. I'm a professional cloud architect certified by Google. I'm a co-organizer of GDG Cloud Mumbai, which is a community run in Mumbai for it's a community of like-minded people, developers who are interested in uh, developing applications with Google Cloud, and the community has more than 4,600 members as of today. I hope, I wish that you guys also, subscribe to this community. We conduct various events, be it, talks by expert, hackathons, or even, a project showcase or those kind of, talks. If see there are these kind of communities are being run in every city. So if you wish to join GDG Cloud, Bangalore or some other community, you can choose to do so. Professionally, I have 17 years of experience now, and I'm part of Quantify Analytics organization, and I'm working as a technical architect. That's about me. And before Okay. Okay. So now, uh, before we get into or dig further into cloud and cloud computing, let me give you a brief or a small definition of cloud computing. I hope this cloud computing definition is quite small and you guys are able to understand. Okay, fine. I don't want to confuse you on day one, but let me, generalize this. Let me, reformat it so that, it becomes easier for you to understand. Okay, it's the same definition, but in a formatted way. When we talk about cloud computing, what does that mean? It means that it's a delivery of computing services. Now, what is delivery of computing services? You might have heard about delivery of products, when you buy something from Amazon, Flipkart, etc. They deliver a product to you. But what do you mean by delivery of computing services? Delivery of computer is still understood. Now, okay, let me come to that little later. Now, let me first ask you, what is computing services? When we talk about computing services, usually it means that it's a service which allows you to do computing, which means whatever your computer provides, that is being serviced, that is being provided as a service. So you're not getting a physical computer, but you are getting those infrastructure or service or those resources as a service. Now, what does that services include? It includes servers, which means your physical machine where you run your applications. It includes storage devices, which means your hard disk, whether it is SSD device or a normal persistent hard disk, magnetic device and all. It also includes databases. All of these organizations nowadays use databases for storing all their data. Networking. If you have more than one computing devices in your network, you need to connect them, and that's what forms the network. Your router or whatever you might be having in your home or your office, that's basically a network. Now, mind it, all of these what I'm talking about are actually not physically delivered to you. It's available as a service to you. So they own it and they allow you to use them. Softwares, analytics, intelligence, all of this is available as services. Now, so now you understand computing service, delivery of computing services. But why is it called cloud computing? Why is it not just the computing? Because it's available over internet, which means that, and generally the internet is referred to as cloud. Why do you call it as cloud? Because it is not physically available at your end. You are just thinking that it's available somewhere. When you look at the cloud, you just see it from here, from ground, but it doesn't really exist anywhere. When you go there, there is nothing actually exists when you are present inside the cloud. So that's why internet is also similar. It's not physically available. When you get connected to internet, you can access the services, and that's why even the internet is considered to be as cloud, and that's why this whole concept is called as computing over cloud, which is cloud computing. Now, why do you need it? What are the advantages you will get out of cloud computing? Why not own a physical machine and not opt for cloud computing? So there are a few advantages why people use cloud computing, and that's why it's becoming more and more popular these days. So one of the advantages, you can achieve faster innovation. What do you mean by that? Let's say today you thought of creating an application. Now, if you want to run this application, you need a computer. Now, you can't deploy it on all the applications on your physical machine, okay? Because you are using it for various purposes. You're using it for development, for your project work and gaming and all of that. So it's a general purpose computer, but you cannot use it for the purpose of deployment of application because that will get occupied. your resources will be occupied there. So rather, you would choose to own a new machine for that. Now, if you have to own a new machine, you might have to visit a store, you might have to make a payment, get it at your home, install the necessary operating systems, and all of that. Now, it's gonna take a lot of time. But when you opt for a cloud computing model, the same application, you can run it within few seconds, within few minutes. Okay, you just have to click few buttons and the virtual computer is available to you. You can directly access that virtual machine and deploy your application. And mind it, it's done within seconds. So when you click a button for creating a resource, within few seconds you get that and you can access that machine. So eventually what you are achieving is a faster innovation. You can innovate your applications very quickly. Second, flexible resources, which means today you want only one computer, okay, to deploy your application. And tomorrow, lots of people have started using your application. And in that scenario, you want to deploy it on multiple computers. You can't go to store again and again to get a new machine. But on cloud, since it's happening very fast, you can click few buttons and automatically you will get those new machines. And you can deploy your applications on all of those machines. So it's very flexible also. It's very flexible to, add more resources to your application. If you think that, it's a off-peak hours and no one is using it, you can shut down that virtual machine. You can reduce the load, not exactly load, but you can reduce the number of virtual machines that you are having for your application. So all of that is possible. Economies of scale. For example, if you are having hundreds of computers for running your one application, you cannot, let's say, if you are having it with your physical machines, you cannot actually keep all those 100 machines in your room. Whole of your room will be occupied with these machines. And the property prices as of today. You can't actually, afford to have physical machines when you scale. And that's why people use cloud computing, because it's not occupying your space. Apart from that, the another advantage that you get is you pay for what you use, which means, let's say you started your application or virtual machine on Monday morning, and Friday evening you shut it down because no one is going to use in the weekends. So you will be billed only from Monday morning to Friday evening. The moment you switch it off, the very next second your billing is off. So that's the advantage you get. Also, operating cost is less because you're not paying the price of a price of a physical machine upfront. If you have to physically buy that machine, you might have to spend like 40,000-50,000 upfront, and then you get a machine to deploy your application. Here, you don't have to pay anything upfront. You pay for what you use. So you use it for Monday to Friday, let's say 5 days, you pay few rupees. For example, like 10 rupees, 15 rupees, that's all. So it's very economical as well. And we have already talked about this, that infrastructure is more and more efficient in this way. You can scale your business application because you get flexibility, so you can scale very easily. So these are the kind of advantages that you get when you are using cloud computing rather than a physical machine. So to summarize, these are the 5, pillars of, how you can describe a cloud computing. It's an on-demand service, means whenever you want, you can switch on the resource and you can shut it down. It's all your wish. Plus, you can automate this. So you fire one API and your machine and your application will be up. You can fire another API to shut it down. So you can automate all of this. Imagine that you had your application running on a physical machine. You couldn't, you have to be physically present at that location. You have to manually turn that machine on. So all of that is physical, whereas here it is automation is quite possible. Broad network access. You don't. It's available on internet, so you can access your machines from anywhere in the world. Whereas in case of physical, you have to be sitting next to that machine to control that device. Resource scaling, as in, all of these cloud providers are having huge infrastructure, and on the same machine they cater to multiple clients. So on the same machine they create multiple virtual machines, and each of these virtual machines might be catering to different organizations. So that's why we call it as resource pooling. Rapid elasticity. So if you think that now lots of people have started using the machine, your application, you increase your basically you can scale your application very easily. In within few clicks you can achieve that, and it will start catering to more and more users. Measured service, just like pay as you go. You might start with a small machine, and then as and when your application traffic increases, you can increase. So you don't have to pay upfront high amount for high traffic that you are going to see in future. So you're starting small, you're paying small at the start, and then you keep on increasing your application, and that time you have to pay more. Okay, so I hope the cloud computing concept is clear. Now, why are we even talking about it, or how did we get to this point? Okay, so let me talk about what was the scenario earlier, what was the scenario when the cloud got invented, and where are we heading towards. Let me talk about the era up to early 2000, when there was no cloud. So all the applications were actually implemented on physical hardware. In your premises, you procure physical machines, server machines. You develop your applications using programming and all. Then you think about, what would be the size of my hardware? Size as in not physical dimensions, but if I'm going to see 1,000 users using my application in one day, then probably I need 4-core CPU machine, 16 gigabytes of RAM, etc., etc. So you might have to come up with this kind of estimations, and accordingly you procure the machines, and you work with the logistics department to get it shipped to your machine, to your organization. Once you have it, you set up the operating systems, you set up all the libraries, softwares, server applications, etc., etc. So these are the logical steps that you have to go through while deploying your applications in physical or on-premise environment. But it's quite a lengthy process. After you created your application, you have to spend like few months to actually deploy your application. Now, to speed this up, cloud came into the picture. Cloud said, you can only focus on application development. The sizing and estimation part will be, taken care by me. Even the procurement and logistics you don't have to work on, because you start with minimal thing and then you keep on increasing. So these two steps are automatically handled, and you have to directly jump onto the fourth step, where once the machine is procured from the cloud, you only have to work on the server applications, libraries, all the softwares that you want to install. Which means that you have achieved quite a bit in speeding up the process of application deployment. But we are heading towards even further scale. where where the fourth step is also automated, which means that you only focus on the application development. Once the application is developed, you just have to upload it as one package. It could be like your zip file, tar file, uh, jar file, whatever. Okay, you just have to upload this file package, and the cloud will take care of everything. They will handle, what machine to procure, how much, what should be the size of that machine, installation of operating system, libraries, all of that will be handled by that. You only have to focus on the application development. And that's what is called as the serverless. Serverless does not mean there won't be any server. It only means that you don't have to focus on server, and that will be handled by the cloud provider. So I hope it's clear that where are we heading towards. Now, talking about some of the statistics, why you should go for cloud computing. Look at the chart on the left hand side. It's a chart running from 2011 to 2020. So it was a survey run by some organization, and it asked few organizations questions like, what is your cloud adoption mechanism, or how much of your applications are cloud based. So 51% of organizations said that we are using some or the other applications which is dependent on cloud. Look at the stat as of today, or as of 2020. 81% of organizations are using applications which is running on cloud, which means that it's a trending technology. All of the applications are now migrating towards clouds. Few years down the line, you would probably see all the applications running in cloud, and that's why it's a right time for you guys to get acquainted with cloud and jump onto cloud. Let me talk about where are we using these cloud applications. Where is the cloud being utilized or used? Okay, so let me talk about some of the applications that you might have used and you might be aware about, and those applications are now dependent on cloud or actually deployed on cloud. Website and web applications. Or most of the website applications today are now actually cloud based. Okay. Do you want to see any example? I hope it is very much clear to all of you, but I don't need to give example for this. But all the web applications, for example, your all the Uber and all of that, all those applications are now on cloud. Collaboration and communication, for example, your Google Meet, Skype, Microsoft Teams, Zoom, all these communication applications are now cloud based. CRM, ERP. So CRM is basically customer relationship management tool. All of these, all your customer care center applications, those use CRMs. So they are actually based on cloud. ERP, you might have heard about SAP, enterprise resource planning and all that. So those kind of applications related to HR, all of these are now cloud based. Mobile applications, for example, Uber, Swiggy, Zomato, Ola, these all applications are now cloud based. BI and data warehouse. So in organizations, usually you have hierarchy. There are managers who are responsible for taking strategical decisions and regular operation decisions, right? So they need some sort of applications or some sort of dashboards to understand the current state of their organization. Now, all of these dashboards are usually called business intelligence applications. So these BI applications are now migrating towards Google or any cloud provider. Apart from that, all the machine learning applications, AI, artificial intelligence, you know, are now migrating towards cloud, because the kind of services that Google Cloud or any other cloud provider are providing are quite useful in a way that, you know, it helps you to build your applications quite easily and very quickly. So a lot of the logistical things are automatically handled by cloud provider. You only have to focus on deciding, you know, what features to add in your applications and all of that. Most of the, see, many people do not have expertise in machine learning, but these cloud providers provide out of the box models which you can use in your application, so that your application development becomes quite fast, and you don't have to focus on, you don't need that expertise also for developing the machine learning models. So by looking at this, it's now, you know, you should start thinking that, you know, it's a high time for you guys, you know, to get started, get associated with these cloud providers, start understanding the kind of services that these cloud providers provide, and what are the kind of solutions that get solved with cloud computing. And it has now become inevitable. You cannot skip, you cannot choose to skip, you know, cloud computing in today's age. Now, that was all about why you should jump into cloud. But here are some, you know, terminologies or some classification of clouds. You know, this will be helpful for you to understand the cloud better. You might hear these terminologies here and there, but I thought, let me, you know, give you some insights about what are these terminologies mean, and probably that will, you know, deepen your understanding about cloud. When we talk about cloud, you can broadly categorize them into two categories, which is private cloud and public cloud. When we say private cloud, it means that, you know, there is one cloud specifically serving for one particular organization, one particular enterprise. Okay, that means in a cloud, in their infrastructure, whatever they have, in the entire infrastructure, they are only serving one organization. They are not sharing it with other organizations. Whereas in case of public cloud, you are having one infrastructure which might be catering to multiple organizations. Coming back to the previous slide, one point that I want to highlight here is all these cloud providers, Amazon Web Services, Google Cloud, Microsoft Azure, they are actually public cloud, because in their infrastructure, they are catering to multiple organizations. Okay, another way by which we can classify these clouds is, actually speaking, it's not classification of cloud, but it's a kind of strategy people use for implementing the architecture of their application. And these words are, you know, multi-cloud and hybrid cloud. These are little advanced topic. You might not, you know, want to dig into this further, but at a higher level, I'll let you know what exactly do they mean. But I would highly recommend that you don't get into this as of now. As of now, you can just focus on the public cloud, and then later on, when you get a, you know, a level of expertise, and then you can explore multi-cloud and hybrid cloud. But let me tell you what multi-cloud is. Multi-cloud is basically, it's a way by which you implement your application using multiple cloud providers. So you might use some services from AWS, some services from Google Cloud, and some from other providers. You know, what is the advantage? Why would you even think about this? You know, if you leverage this strategy, you get best of the breed features. You know, some cloud providers might be providing some services, or might have some edge over different cloud providers in some services. You know, so all of these you can take benefit of. You know, so and another advantage that you can get with multi-cloud is you reduce the reliance on a particular cloud provider. So if Google Cloud is charging, say for example, exorbitant, you might want to use services from other cloud providers as well. So those kind of things you can achieve. Hybrid cloud is one mechanism by which you are making use of public cloud as well as private cloud in your application. Why would you do that? So talking about some industries, for example, banking and finance, they have an auditory requirement or compliance requirement where they cannot send out the data outside of their organization, outside of their premises. So what they do is they usually deploy a private cloud in their organization, and all their data resides inside the private cloud. But they don't want to miss out on the opportunity that they get from public cloud. For example, the scaling, auto scaling, failover, and all of that which is provided by public cloud. They want those functionalities also, and in that scenario, they run their applications on all these public cloud providers, and they keep their data in the private cloud. So it's a little bit advanced topic, but in hybrid cloud, usually people do that. Don't dig further into that. You can dig into that later when you get a little bit more expertise in public cloud. Okay, when we talk about public cloud provider, Amazon Web Services, Microsoft Azure, and Google Cloud Platform are the leaders in this space. There are a few, players as well, which is like Oracle Cloud, Alibaba Cloud, which have recently come up. Okay, the major market share is of Amazon Web Services, followed by Azure, and then by GCP. But GCP is now fastest growing cloud provider in this world. So that is another reason that you should opt for GCP or dig further into GCP, so that by the time you come out of your education or the degree engineering, you are ready with the cloud providers, services and all. Okay, now that was all about a generic cloud provider. Now so all the slides that is going to follow is related to GCP, okay, and why you should choose GCP. GCP has a huge fiber optic network at the backbone, okay, and that's why all their infrastructure is powered by this backbone fiber optic network that increases the speed of communication between all of these resources and all that. When we create a resource in any of these cloud provider, it actually gets created in one of the location in this globe. Now these locations are nothing but zones and regions. Whatever you see here, I'll come to the distinguishing factor of zones and regions. But whatever you see in blue dots here in this map are actually the regions. So there are more than 28 regions available as of now in this world. Now these regions are, some geographical region. These regions does not mean either city or state or a country or a continent. The boundary is defined by Google, okay? But a region is you can think of one geographical region. Each region has 3 or more zones. Now the zones are nothing but that's where exactly your infrastructure lies, okay? So a region might consist of 3 different zones, and each of these zones consists of their physical hardware, where all your computers reside. There are more than, I guess, 150 or so. I don't remember exactly the number, but there's so many zones available across this globe. In India, there are 2 regions available, and all of these regions are actually connected through their fiber optic network. Now, what I'm going to show in the next slide is basically their fiber optic network, which connects all these regions across the globe. Some of these networks are basically, intercontinent connected cables, which means they are running under the sea. It's a submarine cable laid by Google across these oceans to, speed up the communication between these regions or across these regions. So all these blue and green lines that you see here are the undersea cables. Black dots that you see in this image are actually are called edge point of presence, POP. These are nothing but, that's where Google's optical fiber network meets the general internet, your ISPs and all that. That's where they meet. So what happens actually is, let me give you one example. Let's say if you have deployed your application and your machine in North America region. That means your computer is running in North America and you want to access that application from your house, for example, in Bangalore. What will happen is, from your computer, you will fire, you'll navigate to a web page. That web page request will be traveling from your house to edge POP, which might be, nearest POP, could be, Mumbai or something else, over the internet, regular internet, which is usually a slow communication. So it will try to find the POP, nearest POP through the regular regular internet, which is slow communication, and from there, from POP to your region, okay, your application, the communication happens through optical fiber, which means that majority of the your communication is being handled by the Google's network, which is through optical fiber, and only very small portion of your traffic or the communication happens over regular internet. So that's why we achieve a high speed connectivity with your application if you are deploying your application in GCP environment. Moving on, these are some of the top clients of GCP platform, which you might want to explore. But one thing that I would like to point out here is, you would see companies from all types of industries. You would see industry companies from banking, some from logistics related company, some company related to IT, some electronic goods manufacturing, some automobiles. What does this indicate? This indicates that GCP or any cloud provider comes as a boom for all these organizations in modern IT infrastructure. Now, talking further about, what does GCP provide you? When you say, I want to use, GCP, but what does GCP provide? That you should know. So broadly, all the services, there are hundreds of services provided by GCP as a part of the complete Google Cloud Platform. But all of these services can be broadly categorized into these four pillars, four verticals. First vertical is compute, which means that, whenever you develop your application, you want to deploy it. For deploying of any application, you want a compute service. Now, of course, under the compute vertical also there are multiple services available in GCP, which you might want to refer to for choosing the right one. But there are multiple services available, but the compute vertical you would consider when you want to deploy your applications. In the next slide, I'm going to talk further about what are the services available in compute vertical. But let me go through other services first, and then I'll move on to compute. Another vertical that you can consider is storage, which usually deals with databases. There are different types of databases available in GCP suite, depending on the type of data that you want to store and the type of your access pattern. How frequently you want to access, or what kind of workload is going to query this database. That will usually choose what services of GCP. The third vertical is big data. Over the past few decades, all these organizations have now collected so many data in their databases that you need special treatment to handle this huge data. And that's why there are multiple services available to handle, store, process this huge data. And all of these services which is provided by GCP are covered under big data services. There are multiple services available, but I don't want to confuse you at this point of time. But when you get a little bit more expertise, I would recommend you to go over these services. Another vertical or another suite of services that is provided by GCP is machine learning. So depending on how comfortable are you with machine learning development, you can choose these services. If you say that I have an expertise about how to develop the models, how to train my models, after training how do I use it for predictions and all that, then probably you can use services like AI platform. But if you think that I don't have machine learning expertise and I just want to use out of the box services provided by GCP, then you can choose any of these APIs that is listed here, which are designed for specific purposes, but you can use that so that you don't have to train your model, and you just use these APIs and your application development becomes quite fast. I'm going to pay more attention to compute services and machine learning APIs that GCP offers. The reason that I want to give more focus on machine learning is because you might see some of these applications as some sort of magic, and I want you to get started thinking about what kind of applications you can make with this machine learning. And you don't have to pay too much of development efforts to actually implement this. I will give you a number of examples where you can use this, and you can I would let you to start explore about how you can utilize them. Okay, let me start with compute service first. So as I mentioned that whenever you developed your programming code, okay, then you want to deploy your application. Now, how much do you want to get engaged? That decides what service you want to use for GCP. Let's say if you want a complete control over how many virtual machines that I want to control, or what RAM, what hard disk, what networking, security, all of that. If you want to keep control on, then probably you want to use a concept called IaaS, which is infrastructure as a service. And the GCP service that is available as IaaS is called compute engine. So you can choose to use that if you want more control over your application. So abstraction is less in IaaS and you get more control, which means that you have to, you have to do a lot of things to deploy your application. You might want to control your network. You have to apply security rules and all of that. So a lot of burden on you. But if you want to, just get rid of that and you want to say that, I will only focus on application programming and then you take care of all the deployment, then probably you might want to go with PaaS or serverless options. PaaS means platform as a service. So it just asks you the package that you want to upload. So you just upload the package and it will handle all the scaling, deployment, all of that. The way you upload your package decides which service. If you want to deploy as a package or an application, then probably you might want to use App Engine. If you have a very small application, just like a couple of functions, okay, then probably you might want to use service called as Cloud Functions. If you want to deploy it as a container, you might not understand container at this point of time, but if your application is built as a container, then probably there's a service called Cloud Run and Kubernetes Engine that you can use from GCP suite. So again, let me summarize this slide. If you want more control over your infrastructure, then probably you might want to use IaaS model. And if you want to, you want less control, but completely abstracted out, then probably you can use PaaS and SaaS model. Moving on. So as of today, GCP provides 350 plus APIs. To be specific, 351. These APIs let you develop your application very quickly, which means that lot of things are being handled by APIs only. You have to only focus on how to integrate those APIs in your application. For example, you might have seen Swiggy, Zomato, or Uber, or those kind of applications. They show maps, right? So those maps are actually not built by them, not built by these application developers. Instead, they use these cloud providers to provide maps in their application. So a lot of things are actually automatically, you can reuse. You don't have to, so your development cycle becomes quite fast. So similar to maps, there are various APIs available in the suite, which helps you with some or the other, industries or some or the other functions. You can see on the left-hand side some of the categories of these APIs. Moving on. Now, I want to give more focus on machine learning APIs that Google Cloud provides. The reason, as I mentioned, that you can start thinking about where we can utilize these APIs. So I'll go over what these APIs provide you, and then I will talk about where you can utilize these APIs. Okay, first API is natural language API, which means that you just provide a text block, okay? Whether it's a paragraph or a whole page of text, you can choose what to give, or a simple sentence also. You can pass in this text to this API, and in return, it can give you these 4 or 5 things. First, sentiment analysis. So, for example, if you passed in a review comment from the user to this API will tell you that what was the sentiment of the user while writing this comment. Second, entity recognition. What do you mean by entity? Entity is basically standard entities. For example, locations, well-known locations, or for example, cities and states, districts, etc. Other type of entities are dates, name of a person. Those are basically called standard entities. So you can pass in a block of text, and it can find out all these standard entities. You can tell what entity to detect. So, for example, you can tell from this block, tell me all the locations which is referred in this block, or tell me all the dates which is mentioned in this text. Third thing that this API can give you is syntactic analysis, which means that given a sentence, it can find out what were the nouns, what were the verbs, adjectives, and so on and so forth. Text categorization, which means that it can label that these text is talking about these topics. So it can give you some details about whether we are talking about politics and sports, etc., etc. And these all are actually, you don't have to actually train machine learning model for this. You are using Google's pre-trained model to do that. But if you think that you have a specific kind of text which is specific for a particular function or a particular industry, for example, medical domain. So medical terminology, it might not understand. So in that scenario, you can train or you can customize the model based on your domain. So these flexibilities are provided by these APIs. Now, let me talk about some of the examples where you can utilize this API. Document classification. For example, you passed in a huge data set of all the news articles. So it can categorize that, categorize as in whether it is talking about, talking about sports or politics or some technology. So it can do this kind of classification. Another thing where you can utilize this is you can build cool apps like, pass in all the review comments of users, and based on that, based on the sentiments of the user, you can derive at a ratings for that product. A lot of people are happy using it, then probably the rating would be higher. So those kind of applications you can make with this. Another application here you can think of is text summarization. For example, you pass in a huge blog to this API or to this application, and it can summarize it into small paragraphs. Just one second. Okay. So you can summarize your huge blog into small paragraph. Those kind of application you can make. Topic detection, we have already talked about that. Moving on, another kind of APIs that GCP provides is Vision API. So in the previous API, you had to pass in the text. In this API, you have to pass in the image. And from image, it can find out some intelligence, some insights. Now, what kind of things that it can detect from this API? It can detect faces in the image. It can detect standard landmarks, for example, Taj Mahal, or any popular landmarks. It can detect companies' logos. Also, it can label your image. For example, you pass in the image and it can tell you that this image is about busy street, or kids are playing, or for example, it's about some food or some dish. So it can label your images with some labels. Text detection. For example, this is very upcoming thing, and a lot of industries are moving towards this or using this. You pass in an image, and it can extract the text out of it, which you can store it in your database, and then you can make it searchable, which means that you can detect or search the images. Not just that, you can use it for the purpose of digitization of the documents. For example, uh, invoices and logistic related documents and all of that. In earlier days, where these documents were physical copies. So what used to happen is these companies used to maintain these documents in physical format. But now all of these organizations are moving toward digitization. So they are clicking a snap of these documents, they are scanning it and storing it in digital format. But just having it as a picture doesn't help. You cannot use the text out of it, and that's why you usually use the something called as optical character recognition. So you pass in the image and it will extract out all the text from it, which you can process it for your further use. Another kind of information that you can extract is image properties, which means you pass in the image and it will tell you what are the most prominent colors in this image. Object localization means if given an image consisting of many objects, for example, busy street might contain, traffic light, a lot of people walking around, a lot of cars moving around, So you pass the image and it can localize all of these objects. It can find the area or the bounding boxes of all these objects. So not just detecting the objects, it also tells you where exactly in the image this object persists. Another use case that you can think of is crop hint detection. So if you are clicking a picture which consists of the prominent object in the center and rest of the information is junk, then it can tell you that you can crop the image from this bounding box. Web entity searching. For example, you pass in the image and you can tell it, get me all the images similar to this over the internet. Okay, so it acts like your search engine. Another use case is explicit content detection. For example, somebody has uploaded an image in your application. Now you want to check that this image does not contain any adult information, or for example some sort of violence related information. So you might want to delete those files upon detection. So you can use this feature called explicit content detection for that. Now, given these features, what kind of applications you can build out of it? One is image recommendation. So given an image, it can detect all the similar objects and it can give you recommendations if this is similar to that. Another use case is vision product search. For example, you pass in an image of a boy wearing a jacket. So you can build an application which can search all the shopping sites having those kind of jackets in their product list. So those kind of cool application you can build with this Vision API. Another thing that you can do is document classification. For example, when you go to bank and ask them to create or open a new account, they will ask you for lots of documents. For example, your driving license, Aadhaar card, PAN card, etc. So you provide all of these documents, and let's say they scanned these images and kept it in one folder. That so-and-so person's all physical document or all the documents are kept in this folder. But later on, if your organization thinks about classifying these images in such a way that all the Aadhaar card should be put into one folder, all the driving license in another folder. So those kind of applications you can build with the help of classification applications, and you can build it with Vision API. Another use case is digitization of documents. We have already talked about that. Now that's about Vision API, which requires image as the input, and you can get the insights from it. The next API is video intelligence, where you pass in the videos to the API. And all the features that exist for video, for image intelligence, Vision API, similar features are available in video intelligence as well, which means you can detect logos, you can detect labels, text from the video, all of that. You can also extract it can also detect celebrities in your videos. Plus explicit content detection, as I mentioned, adult and violence kind of thing, it can detect from that. Another added advantage with video intelligence is object detection and tracking. So it not just detects the object, but it also tracks it. That so-and-so person is detected as an object, and he is moving from this end to that end. So that tracking is also possible with the help of video intelligence. Short change detection. Now, where you can utilize this is, I'll tell you. Let's say you have a CCTV footage of a particular room, okay? And let's say it's a very idle room, not too much of activity happens in that room. Now, a robbery happens in that room, and you are asked to, find out who is the, who is the culprit behind that. Okay, so you have been given a CCTV footage to find that out. You can't actually spend whole day to see the footage of that particular day, and that's where short change detection comes into play. It can mark out all the times when it saw some short changes, some activity happening. So that's a kind of feature that is useful to you. Automated subtitles means whatever audio is being played in the video, automatically you can generate the subtitles for that. You might have seen that in YouTube, it is already present. Now, what kind of applications you can build out of it? You can create a cool applications for content moderation. So based on, you can decide your rules, criteria and all that. If you find this kind of, videos, then probably you might want to take certain action. For example, discard off or notify the person who has uploaded it and all of that. You can use it for recommending the content, which means that, if you are seeing certain thing in the video, you might, based on what is being played in the video, you can recommend different videos also, if they are, similar. Another use case is, contextual advertisement, which means that you might have seen YouTube, based on whatever YouTube is being played, YouTube video being played, you see the advertise which is very similar to that video. And that's possible with the help of contextual advertisement. You can build it with the help of video intelligence. And in fact, YouTube is also using the similar technology. You can make videos searchable. For example, you have a huge bank of videos, okay, kept in a folder. You can pass them to video intelligence, and you can make videos searchable. For example, you can find out all the videos that has elephant in the video. Okay, so it not just detects the videos which has elephant, but it also marks out at what point of time the elephant was shown in the video. So that search engine can be implemented with the help of video intelligence. The fourth API that I want to talk about is translation API, which means you can use it for translating your text or images from one language to another. You might have already used it in Google Lens. It's the same service. There are hundreds of languages supported as of now. But if you think that your language is not supported, then probably you can, build a custom model also. So those kind of customization is supported by this API. And the quality that is provided by this API is best in class. No other cloud provider provides this kind of quality. You can use it for the purpose of internationalization of application, which means you want to make it make your application viewable or readable by people across the globe. Localization, which means your application is in some different language and you want to see it in English or in your native language, you can use this APIs. I hope by now you are clear about what kind of applications you can build with this services provided by GCP. Now, and I wanted to, put some thoughts in your mind, that, you can get started now with this GCP and, you can build some cool stuffs. All these, Swiggy, Zomato and Uber and all that were at certain point of time were just an idea. And then they implemented it and now today they are like a huge applications. And you might have seen huge IPOs also of these applications in recent past. So even today, you guys can start thinking about those cool small applications, and then when you get an expertise on that, you can start building those ideas. Now that's about what you can build out of GCP. Now what I'm going to talk about is how do you start with GCP, which means that you want to get started, but how do you start building on this, or how do you start learning more about GCP? So I have jotted down few points which you can use it for upskilling yourself and getting started on this journey. So you can directly log into console.cloud.google.com and create your account. And when you create your account, you get a free $300 free trial credit, which means you can use it for the purpose of creating any resource in GCP. This resource could be a simple virtual machine where you deploy your application, or it could be simple API call. The ML APIs that we talked about just now, you can call those APIs directly. And these $300 can be utilized for that purpose. Or you can choose to create a database, okay, with this $300 credit. And you won't be charged anything. But make sure that you switch it off when you are not using it. Otherwise, your bill will keep on growing. And at certain point, this $300 will get exhausted and it will start charging you. So have that discipline when you get started with Google Cloud or any cloud. If you don't like browser way of accessing it, and if you prefer to use command line access, then probably you can download Google Cloud SDK and you can start typing G Cloud in it and you can get started. As in, you can start creating your project, subscription, and you will get $300 subscription. Okay, now that was about how do you start, but let me talk about how do you upskill yourself? How do you learn more about GCP? So Google Cloud has a very good documentation. They have created lots of tutorials, okay, and those tutorials are available to you free of cost for first 30 days. Okay, so you can select when to start, but make use of these 30 days as much as possible. And all of these tutorials that they have written are actually written by Google Cloud developer advocates. Okay, so it's a uh, and the clarity and the description that they have mentioned in the tutorials is quite user friendly. Even the beginners can understand it very well. It's a it is explained in such a elaborative manners, like click on this button, so they would give a picture of that what screen you will see. Click on this button, then probably you will see this. When you see this, you click this button, etc. So it's very step by step process, and that lets you understand all the services which is provided by GCP. If you prefer a kind of YouTube channels, so here are some of the channels and the playlist provided by Google Cloud that helps any beginner to get started. Quick Labs is one of the tool that is usually a kind of tool for hands-on experimentation. And Quick Labs also provides a defined quests and labs. Quests are nothing but your learning path. So you can choose what stream you want to get expertise in, and for each stream they have provided a learning path in terms of quests, and each quest consists of number of labs. And these labs are nothing but a hands-on, step-by-step labs where you can try out actually on Google Cloud. I believe Quick Labs is one of the best tools in today's world. Probably you should make use of this as much as possible. Coursera is one of the online platform where you can you can choose what kind of expertise you want, whether it is security related or database related. You can choose your learning path, and there are courses available for each of these specialization. And and of course Coursera provides 1 month of, I guess, free subscription. So within 1 month you can choose as many courses that you want. And once you complete a course on Coursera, you can publish your accomplishments on LinkedIn and Twitter, so you can share it there. We cannot forget Google Cloud's documentation. They have provided reference architecture for all sorts of application that you want to deploy or you want to build. So and the kind of documentation is it's one of the best in this industry. I have compared documentation of various cloud providers, but the kind of clarity that Google Cloud provides in its documentation is marvelous. You won't find it anywhere else. With this, I would recommend all of you to try your hands yourself. And if you have any questions, I'm always available. With that, I want to put a distant goal for all of you. There are so many certifications provided by Google Cloud for different level. If you are quite beginner, you can choose to be a associate certified professional. Once associate certification is done, you can choose to go on to or move on to professional certification. And in professional also there are various categories you can choose, whether you want to gain expertise in data engineering side, or machine learning side, or cloud network engineer. So you can choose various paths, but you can choose to go into professional certification as well once you have little bit of more expertise. But put these certification in your goal chart, once you complete your 30 days course. With that, I would like to end my presentation here. I am available on all these social media platforms, and my handle is common across these platforms. It's Nirav Kothari. I'm quite active on LinkedIn and Twitter. If you have any question related to GCP or you need any kind of career guidance, I'm always available. Not just now, but in any time in future. If you have any queries, you can reach out to me, and I'll be very much happy to help you out. With that, I would like to end my presentation. If you have any queries, I'm more than happy to answer that. Host, I would need your help. I'm not seeing the chat list. So if anyone has any query, please, ask me over the voice. Thank you.
Guys, anyone have any queries? You can ask. Guys, put your queries in chat. I guess no one has any queries.
Sure. No worries.
Yeah, I have a like query or doubt. The thing is, this Google, I mean the cloud architect and cloud developer. What is difference between like these two roles or the certification you like earlier said?
Sure. So basically, developer is basically one who's actually working on these services, creating
Hmm.
these services, then using these services, and probably testing out also.
Okay,
Whereas architect is more about, there are choosing of or designing a solution. So there are hundreds of services available, but out of these 100 services, which ones to use? So they design these solution with the help of these multiple services.
okay.
I hope it is clear.
Yeah, it is clear. Uh,
But you need a broad spectrum. Uh, I mean, broad understanding of the wide spectrum of these services to become
mhm.
an architect. Whereas to be a developer, you can start with individual things. For example, you can choose to go ahead with security engineer as of now, or data engineering related stuff. So you can start with a developer or engineer at the start, and then when you get expertise, you can move on to architect path later on.
Okay, thank you. Uh, no queries. What we are going to do in the 30 days challenge. So basically we have two tasks that is mentioned there and we'll be like doing that task. Like few quick labs are there. We'll have to solve those labs in this 30-day challenge. Anyone have any query related to Google Cloud or like uh, this cloud thing? You can ask. Okay. So I don't think like anyone have any queries.
Okay. So we can actually close down, and if you guys have any questions, you can send me offline as well.
Someone is asking how secure is cloud?
Okay, absolutely secure, absolutely secure. The kind of security that you can achieve with your machines, physical machines, probably a lot more than that you can provide with cloud, because they have invested lot and lots of years to implement this securities for cloud. So and best of the engineers were employed to provide this security. So what you can think of is, you have employed the cloud engineers, or the Google Cloud engineers to provide security to your applications, because lots of security measures are available that you can configure in your when you create any resource in GCP, and that makes your application much more secure than even the local applications.
Okay. Some more questions are coming. What is edge computing?
Okay, so edge is specifically for is spoken in terms of IoT use cases. Usually, there are two types of processing in IoT. In IoT is basically, there are some sensors which is sensing certain environment parameters, and then you have uh, so sensors keep on sensing this, and it keeps on sending it to the cloud. So cloud stores all these parameters. You might not have all your databases on where on premise, where it is actually sensing all the parameters. So you might not have all those infrastructure on premise. You usually choose to have it in cloud. So there's a piece of code that is running on premise which keeps on sensing this data and sends it continuously to the cloud. And there on cloud, you do two kinds of things. One, store this data, and second, you process this kind of data. Process as in you might transform this data, you might write some sort of predictions, uh, predictive analytics kind of machine learning models and all that. So all of that you can implement it in the cloud. Whereas on premise, you are only sensing the parameters and sending it back to the cloud. But nowadays, that on-premise thing is actually called as edge computing, where you are not only sensing and sending, but some sort of intelligence is also provided in those machines, so that it can take quick action. So any action, any say for example, any parameter has changed, you don't need to wait till sending it to cloud. Then cloud will decide whether something needs to be some action needs to be taken. For example, switching off your camera or switching off your AC and all that. You need not it need not be happening through cloud. You can take certain kind of actions on premise itself, so that you can reduce on the response time, and that's what is called as edge computing. Is it clear?
Okay. Yeah, I guess it's clear.
Okay.
Someone is asking which is easy to learn, GCP or AWS?
Every cloud has its own way of creating resources. All these resources are, it's internal to their platform. uh, I believe when you pick one, you would be, conceptually they are same. So when you learn one, others would be much easier for you to grab. So start with one, and then you can go with other cloud providers. As of now, I can't say which one is easier and which one is difficult, but I like the user experience of Google Cloud than any other cloud providers. User experience is quite friendly, user friendly, and much clean.
Okay. So okay. So we don't have any other questions as of now. If someone have any query or question, you can like contact on other social media platform and you can ask directly to sir. So yeah, Ria,
Thank you so much for your insight on everything, sir. We thank you for giving us your precious time, and I'm very sure that your words were extremely helpful to all of us present here. With this, we come to an end of today's webinar on cloud computing. We will keep bringing you more such events in the days to come, and we look forward to your active participation in the 30 days of cloud. Thank you so much.
Thank you. Bye bye.
thank you so much, sir. Bye.